In this video, I'm going to go over a couple of examples related to working backwards in area problems. You should have already reviewed the different area formulas that we're going to be applying. There are examples there, and I will provide some supplemental videos if you need some assistance with those, but we're going to move on and just look at if we need to work backwards when we're given an area and have to calculate a portion of our figure. In our first problem, we are given a parallelogram with an area of 160.5 square inches that has a height that measures 7.5 inches, and they ask us to find the length of the base. The first thing that you should always do in a problem like this is draw your picture. So in my picture, I already created my parallelogram. Now I am going to draw in my height, which is 7.5 inches. And I know my area is 160.5 inches squared. You notice that the base and the height are always going to be perpendicular to each other. So if you're ever looking for the height in a figure, and this could be in a 2 or a 3-dimensional figure, you're always looking for whatever is perpendicular to your base. So you're looking for that right angle. So our first step whenever we're working backwards is to write down our area formula. So area equals, for a parallelogram, it's base times height. Now there are two ways that you can do this. The first one we're going to do is where we substitute our values in first. So I'm going to substitute in my values and I get 160.5 equals 7.5 times the base. You notice that I am not including my units during this part of my calculation. I just do that to make my formula a little bit more simple, and then I'll consider what my correct units are going to be at the end. Now, in this case, I'm going to solve for b by dividing both sides by 7.5, and we get that b is 21.4 inches. Since we are doing area and we're doing lengths and areas, you need to include units in your answers. Now, another way that you could do this is after you have your formula written down, you can solve it with the variables already in place for whatever you're solving for. So in this case, if I have area equals base times height, and I know that I'm looking for my base, I can divide both sides by the height. And then we get base equals area divided by height. At that point, I could plug in my values and I'll get the exact same answer that I did plugging in my values at the beginning. This can be nice though if you want to have to just do one calculation on a calculator. Let's do one more example. In this case, we are going to find the length of the second base of a trapezoid with one base measuring 12 feet, a height of 4 feet, and an area of 58 square feet. So as you can see, I've drawn my trapezoid, and I'm going to label the values that they give me. They tell me that one base is 12. I'm labeling the longer base, but I don't actually know at this point if it's going to be longer or shorter, so we'll just wait and see. I know my height is 4. Once again, I'm showing that my height is perpendicular to my base, and I know my area is 58 square feet. So we can solve this by writing down our formula first. Area equals, let me use a wider marker. Area equals 1/2 b1 plus b2 in parentheses times the height. I can substitute in my values, so my area is 58 is going to be 1/2 times 12 plus b2 times 4. So we know what I'm going to do first. I'm going to simplify on my right side the 1/2 times 4, and we get 58 equals 2 times 12 plus b2. And instead of distributing first, which you could do, that would be fine, I'm actually going to divide everything by 2. Because if I divide this whole side by 2, those are going to cancel each other out. And then I can do 58 divided by 2, which is going to give me 29. So we get 29 equals 12 plus B2. I subtract 12 on both sides, and we get that our second base is equal to 17 feet. And once again, you notice that I have my units in my answer. Thank you very much.